here.
Fantastic.
I'm here.
Yes, you're here.
Okay, great. So let me introduce Center for Net Zero, which is a impact-driven research lab that's owned by Octopus Energy. And Octopus Energy is actually more than a retailer. We manage investments into renewables, we manage EV fleets, we manage installation of smart meters and heat pumps throughout the country as well. And I manage a project called the Clean Energy Cities project, which is seeing how cities can be really the solution and not just the problem for the energy transition in the future. And our challenge for today is called managing EVs as a floating resource. So what the hell does that mean? So it means first we're going from a situation in the recent past, it's a linear system. Generators generated, people used energy, and it just cascaded from generator to substation to person. And we're going to be in a situation in the near future where local generation and storage is going to be within cities in almost an infinite number of virtual microgrids in the future, where buildings and streets are both generating and storing electricity to meet peak demand in the future. And one of the things that drives that, of course, is real-time pricing that reflects the cost at that hour. And of course, the most costly energy right now is coal and gas, and the cheapest is solar and wind. And that will continue in the future. Next slide. One of the things that comes into this is the electric vehicle and its battery. And there's a concept called smart charging, which I'm sure most of you have heard about. That the charging goes in both directions. You both charge the car, and it discharges into the grid as well. And it discombobulates people to think that their car can lose charge as well as gain charge. But actually is some of the products that are going to be offered by energy retailers in the future. And actually we already do right now, where you get cheap electricity in return for us taking it away from you when there's peak demand. And this is something which will save huge amounts of reinforcement investments by grids in the future, and things like planning contributions for builders. Next slide. And we also know, unfortunately, that a huge amount of solar and wind isn't being used because there's nowhere for it to go. And right now it's about 7%, and it's going to go much higher in the future. Next slide. And that's because the flexibility in the system, and this is an estimate by National Grid themselves in the UK, is going to more than quadruple in local areas over the future. And it's going to change from something which is dispatched at a big network level to something that is really held at a local level, inside of home batteries, inside of local generation and storage. Next slide. And we know that the combination of real-time pricing, having storage there in the system for being used at peak times is going to be important, but building owners are often going to be quite hesitant about investing in huge battery systems that could be quite costly in the future. And that's why EVs are just a cheap and available resource, because people are buying cars. They are being changed over from petrol cars into EVs. But how do you harness that? They're just sitting there on the streets. And how do you actually build that relationship between those who own the premises and own the smart chargers and the EVs that happen to be there, because it's the time of day they'll be there. Next slide. So we tried to imagine, this is a city block, we just went to Paris and launched our project, and this is one of the research pieces that we did. We imagined a city block and said there's 200 residents there and 20 businesses there. Next slide. This is what they do now. You expect them to see right now that because the commercial premises, it starts rising in the morning and afternoon, and because of the residential premises, it keeps on rising into the evening. All very expected, but obviously you have to fire up fossil fuels, have higher baselines of nuclear energy to be able to meet that peak demand, and you actually want to bring that peak down and make the whole system cheaper and more sustainable. Next slide. So we tried to do what cities normally do, which is just have a residential only policy, because that's what their voters demand, is what they understand. A lot of times, no criticism at all. I just was a civil servant. But it doesn't actually solve a lot of the problem, because you still just don't get enough stored energy in the system from charging up batteries in the early morning to actually start to meet that peak demand, which there's no solar generation and less wind generation happening during that time. Next slide. But if you get both the domestic sector and the non-domestic sector involved, you actually start to get, and this is assuming a very mixed block land use mix that's there, you almost what we call a 24/7 constant import of electricity from the grid, which is super cheap and super manageable by the grid. And that's something where you want to get to that point, but it asks for a lot of storage within the non-domestic sector. And they might balk at that and say, well, what about all these cars that are sitting here during the daytime? Next slide. So this is the challenge that we have, saying, how do we actually manage these as a floating resource? There are actors that are there. There's the premises owners that are in city centers or own commercial premises in neighborhoods. There's those who own EV fleets. There's the commuters that are involved that have their EVs going from residences into businesses and back again. And of course, there's the retailers that everyone's associated with your own tariff that you have in your buildings, the tariffs that are on the smart chargers that are on your premises, the ones that are associated with the residential areas that those cars might go to in the evening to try to relieve that peak. So there's problems that are there. So given where the EVs are, how do they manage as a resource? Whether they're fleets, whether they're commuters. What about the data flows between the EV owners, the premises owners, the retailers, and others? And are there strategies that local and national government need to take to manage that? And the things that we can provide as somebody who has a lot of data about EV owners, we actually have some special tariffs that entice people to use it in the early morning to charge up their vehicles. And we actually have ones that take full control of the cars and the charging that's there. And we actually have the data about how people behave when they actually do that during that time. And we obviously have real-time pricing for a lot of our consumers that we call Agile Octopus. You can see how real-time pricing actually will work in the future once it extends to the whole industry and influences how everyone has in the future. And obviously, we have, myself as an urban planner, a lot of the urban blocks and typologies that will have, we have to test to see what is the mix of uses, storage, and EVs that actually start to make it work. So it's an opportunity for many different actors involved. Thanks.
Brilliant.